Hello MacroHard community, welcome back. So today we are going to discuss a very interesting topic. So earlier we had discussed about oracles. So we know that oracles is any external information, and this information can be price feeds outside the chain or other data from other platforms. So oracles can be broadly of two types. The first one can be a game theoretic oracle like Chainlink, and the second one can be an inbuilt application oracle. So in the first type of oracles, we know that there is a group of miners who regularly give out the price feeds, and before doing that, each of the miner stakes certain amount of money. Now we assume that each of the miner will behave honestly, because if they don't give the correct price or the correct numbers, then their staked money will be slashed. Now this creates a bottleneck in the security of such oracle designs. So for example, if all the validators together stake up $100 million, then it only needs $50 million theoretically to break this oracle system. Now this design can have single points of failures, because you can bribe certain validators, or you can become a malicious validator and stake a lot of money and gain the majority power, and then you can provide incorrect data. So in order to mitigate such problems, we can have the second kind of oracles, which is platform inbuilt oracles. And the best example to illustrate such kinds of oracles is the one provided by Uniswap. Uniswap uses the TWAP oracle. Now this stands for time weighted average price oracles. In order to understand this, let's take an example. Suppose we want to fetch the price of Ethereum versus dollars from the Uniswap TWAP oracle. So what we can find from the Uniswap platform is that what is the current value of the pools in the ETH USD pair, because all we want is the ratio between the amount of Ethereum and the amount of dollars in the pool, and this ratio will give us the current price. So one direct observation here is that if someone wants to manipulate this kind of oracle for Ethereum price, then he has to manipulate this pool of Ethereum versus USD. So if this pool contains hundreds of millions of dollars worth of crypto, then it becomes very expensive to just manipulate price of one crypto pair. Moreover, when this malicious actor manipulates this price, then his capital is subject to arbitrage and he can lose a lot of money. So one additional feature which this Uniswap oracle has is that it doesn't get affected by sandwich attacks, which means that if an attacker has a lot of capital and then he creates a very large buy and a very large sell order in order to manipulate prices, and then he sandwiches a transaction which uses the manipulated price in between these two big transactions, then he can exploit this false price data. But such a kind of exploitation is not possible for these kinds of oracles, because these oracles uses the fact that only the first transaction in the block affect this oracle price, and every other transaction in the block is not counted. So all in all, inbuilt oracles inside platforms are very robust to manipulations. So therefore, each platform that is providing certain kind of service, even if it is lending service, then it should provide an oracle service as well for the kind of data that the platform is generating. So this allows other platforms in the same ecosystem to leverage the use of these robust oracles, and this increases the overall use case of the ecosystem and enhances the overall value. So that was all for today. If you find this video insightful, then press the like button, and if you're new to this community, then subscribe to MacroHard. See you all tomorrow. Until then, bye bye.